Suppose you had a fair coin and flipped it 8 times, as I'm about to do right now. What's the probability that more heads will show up than tails? Pause the video and give it some thought, and when you're ready, join me for the solution. This problem actually appeared on the GRE subject test in mathematics. Surprisingly, only 54% of the college graduates taking it at the time got this question correct. I'm confident we can do better. I'm going to present 2 methods. For the first method, I'm going to display all the possible outcomes that would have more heads than tails. So the first, as shown, will be flipping all 8 heads. Next will be 7 heads, 1 tail, then 6 heads, 2 tails, and lastly 5 heads, 3 tails. The probabilities for each of these outcomes can be calculated using the binomial formula. N will equal 8 since we're doing 8 trials or flips, and K will correspond to the number of heads in each of our 4 outcomes. Little p is the success probability, which is 1/2 for heads, and 1 minus p is the failure probability, which is also 1/2 for tails. For our first outcome, we'll have 8 choose 8 times 1/2 to the 8th. Next, we'll have 8 choose 7 times 1/2 to the 7th times 1/2. Then 8 choose 6 times 1/2 to the 6th times 1/2 to the 2nd. And last, we'll have 8 choose 5 times 1/2 to the 5th times 1/2 to the 3rd. Now we need to add all 4 of these probabilities. I'm going to first write all the halves as powers of 8 using the exponent addition rule. Next, I'll factor out 1/2 to the 8 from all 4 terms. Now we can start evaluating these binomial coefficients using the formula for n choose k. Now I'll rewrite the 8 factorials in the numerators in such a way that we get nice cancellations with the factorials in the denominators. The 8 factorials cancel, the 7 factorials cancel, the 6 factorials cancel, and so do the 5 factorials, leaving us with this. Each of these 4 terms becomes 1 plus 8 plus 28 plus 56, which adds to 93. And since 2 to the 8 is 256, we get our answer, 93 out of 256, or about a 36% chance of flipping more heads than tails. But that was somewhat tedious. Can we do this more efficiently? You bet. If we consider the probability distribution for each of the possible outcomes, we would get the following graph. Notice that I colored the 4-head outcome in red. Why? Because that's the only one we need to calculate. And we know from the binomial formula it will be 8 choose 4 times 1/2 to the 4th times 1/2 to the 4th. Because of the symmetry of the distribution, we can set the sum of all the blue outcomes to the left of the red bar equal to p. And similarly, all the blue outcomes to the right of the red bar also equal to p. The sum of all the possible outcomes must equal 1, from which we can say that 2p plus the 4-head outcome in red must equal 1. Just like before, we'll add the exponents to get 1/2 to the 8, and we'll evaluate 8 choose 4 just like before. A pair of 4 factorials cancel out, leaving us with this. Since 8 times 6 is 48, and 4 factorial is 24, we just get 2 times 7 times 5, which is 70. 2 to the 8 is 256, so we have 2p plus 70 over 256 equals 1. I'll write 1 as 256 over 256 and subtract 70 over 256 from both sides. 256 minus 70 is 186, and dividing both sides by 2, we get p equals 93 over 256. Let me know in the comments if you got this question correct and which method you used, or did you do something entirely different? Thanks for watching, and see you soon.